Lesson 67 is about solving simultaneous equations by using a method called elimination. Now, in the Saxon book, they introduced this by reviewing equivalent equations. I don't think that's a very good way to introduce elimination. I think it'd be better just to review simultaneous equations and the substitution method and then explain to you how there's a different way to solve these problems, and that's called elimination. Now, in lesson 54 is where we learned about solving simultaneous equations using substitution. Remember, simultaneous equations, what we call those are two equations that can be are linear equations, and if you graph them on a Cartesian coordinate system, they would be lines. And when we solve them together or simultaneously, we're solving for where those two lines would intersect. And there's a specific point, and that's what we're solving for. We solve for the x value and the y value in that ordered pair. And so remember, substitution, what we could do, like in this example I have on the board, we could take the x plus 7 in y equals x plus 7 and substitute it in that bottom equation for y. Since x plus 7 is equal to y, that's the reason we can substitute it in for y in the bottom equation. And so we would just say x plus 7 equals 2x plus 1. Then we could use our additive property of equality to get the x variables just on one side, and we could add a negative 2x to both sides. And while we're doing that, let's go ahead and move the constant by adding a negative 7 to both sides. So the 2x's would cancel, the 7's would cancel, and we'd end up with negative x equals negative 6, or just x equals 6. So there's our answer, 6. We need the y value too, so we have y equals x plus 7. We can go ahead and just substitute that 6 back in up here. Y equals 6 plus 7. That equals 13. And so our answer, we write it as an ordered pair, 6 comma 13. And so at that point, that's where those two lines would intersect if we graph them on a Cartesian coordinate system. When x is 16 and y is 13, that particular point is where they would intersect. Remember also, once we solve for one of the unknown values, we can substitute back into either equation. It doesn't really matter. Like I could have used the second equation there, y equals 2x plus 1, and I would have had 2 times 6 plus 1, and I still would have got y equals 13 for an answer. As long as x is the correct value, x equals 6 is the correct value, we'll get the same answer in both of them for y. So now, let's just take those same two equations, y equals x plus 7 and y equals 2x plus 1, and let's solve these by this new method called elimination. And just think of the word, elimination. Just like in substitution, that makes you think of substituting something in somewhere else. Elimination, you're going to eliminate something. And you know what you're trying to do here, like when you do substitution, you're trying to just get one equation that has one unknown in it, or one variable. That's what we're doing in elimination as well. We are eliminating a variable. We can do that by combining these two equations using addition. Now, if we did that right now, if we added those two equations together, we'd just have 2y is equal to 3x plus 8. But that hasn't helped us any. That hasn't eliminated a variable. So what we do is we change one of those two equations to an equivalent equation, and that will eliminate a variable. And we need to do that in a way so that it does eliminate a variable. For example, look at the two y's. We have y and a positive y. Both of those are positive y's. Make one of those a negative y, and then if we add the two equations together like we just did, the y's would cancel. So it doesn't matter which one we make negative. Let's just do the top one negative. Remember our multiplicative property of equality. If we multiply one term by a value, we have to multiply all of the terms on both sides of the equal sign. So this becomes a negative x. This becomes a negative 7. And that might be a good idea for you, just to use like a different color pen or pencil to keep up with your steps. Now let's add them together, and we will see that we will eliminate the y's. Negative y plus y is 0. equals x minus 6. Okay, so we have 0 equals x minus 6. We need to get the x by itself, so we would just add 6 to both sides, and we get x equals 6. Just like we did using substitution. You should get the same answer either way because it's still the same lines. They're going to intersect at the same spot. We're just using a different method to get our answers. Now you go back and substitute in the 6 to solve for y in either equation. Use the original equation, the one you have before you changed it. So just use y equals positive x, so that'd be a 6 plus 7. And again, that's a place where the different colored pen or pencil there to put your negative signs in, that would help, so you know that when you go back and solve for y, you don't use those negatives. I mean, you can, you just have more negatives to work with to solve for your answer. So that equals 13, just like we had before. So 6 comma 13 is the answer. And like I was saying, you could solve that. We could have said negative y equals negative 6 minus 7, and we still would have got y equals positive 13. But it's just easier to not have to deal with all those negative signs in a problem. So just don't use your equivalent equation. Use the original one to solve for it. Now when we use elimination, there is more than one way we can do elimination. Let's just take the same example, y equals x plus 7, y equals 2x plus 1. We could have multiplied every term in the bottom equation by a negative 1 as well, and we still would have had the same result. We could have multiplied every term in the top equation by a negative 2, and if we did that, negative 2, and then I'll say times negative 2 over here. If we did that, then we would have eliminated the x values. So you can do it that way as well, but see, that's just a lot more complicated than the first method that we used. And so that's something that you want to keep in mind on these elimination problems. Look at the problem, evaluate it first, just kind of go through it and think about what would be the simplest way to eliminate a variable. So look at practice problem A at the bottom there. Let's use elimination to solve that problem. Okay, so let's look at it. 2x plus 3y is 8, 3x plus 4y equals 14. I don't see anything right away that says that would be the most efficient way to solve it. So let's just go ahead and pick one of those two variables to eliminate. Let's just decide which one we want to eliminate. And so we'll eliminate the x. That's what I'm going to decide here. We could eliminate the y. It doesn't matter. I'm just going to choose to eliminate the x. And so what I'll do to do that, I'd have to multiply every term on top by either a 3 or a negative 3. I'll go ahead and multiply every term on top by a negative 3. So I'll put these parentheses and a negative 3 on the outside to remind me that I'm doing that. And then every term on the bottom I'll multiply by a positive 2. That way on the top I'll have a negative 6x, on the bottom I'll have a positive 6x, and that way those will cancel. So let's go ahead and expand this out, and so I'll have negative 6x minus 9y is equal to negative 24. And then on the bottom I'll have 6x plus 8y is equal to 14. Now I'll add those two equations together, and the 6x's cancel, and I'll have negative y is equal to negative 10, or y equals 10. Now I go back and substitute that 10 into either of those equations. Neither one of them looks like it would be easier to substitute in than the other one, so I'll just pick the top one, and I'll say 2x plus 3 times 10, that's the y equals 10, so 3 times 10 is 30, equals 8. Subtract 30 from both sides, and so we would have 2x is equal to negative 22. and therefore x equals negative 11. And so we want to write our answer as an ordered pair, and I'll put it over here on the right, negative 11, comma, 10. That would be the solution, negative 11, comma, positive 10. We can always check our work to make sure. Let's substitute those two numbers back into the bottom equation, and that would give us a negative 33 plus 40. That does equal 7. So that helps us know that we did that problem right. So we picked one of the two variables to eliminate. We just decided we were going to eliminate the x. We could have eliminated the y first, and then we decided how to do that. We were going to multiply so that we got a 6x for both of them. One of them was a negative, one was a positive. We decided to multiply the top one by negative 3, the bottom equation by negative 2. Doesn't matter, we could have multiplied the top one by a positive 3 and the bottom by a negative 2, but that's just what we decided to do. So when you do these elimination problems, you have some choices to make on how you're going to solve the problem. In the end, the only thing that matters is that you have the right answer. Let's do one more. X minus 4y equals 3, 5x plus y equals 15. Now, we could use substitution to solve that, but in the lessons and on your test, they will specify whether they want you to use substitution or elimination. So make sure you do it the right way. Within elimination, though, you have a lot of freedom as to how you solve it. First, look at the two equations and just pick one of those two variables to eliminate. Neither one of them looks necessarily like it would be easier to eliminate than the other. So I think what we'll do here is eliminate the y's first. And what we could do is just multiply the bottom equation by 4, and that would eliminate the y's because we have a negative 4y and a positive y. And actually, eliminating the y's is a little bit simpler because we already have opposite signs. Remember, that's something that you have to do, is get opposite signs in order to eliminate. Since we already have opposite signs, y is easier to eliminate than x. It's just a little less math to work with. And that's what you want to do, right? You want to do it the most efficient way, the way that has the less math involved. So the best thing to do next is to rewrite both equations, one on top of each other, with the new equivalent equation on the bottom. So we have x minus 4y equals 3, and then 5x times 4 is 20x. 4 times y is plus 4y, and then 4 times 15 is 60. So now we can add those together, 21x, and then the y's cancel, equals 63. Divide both sides by 21 and we would get x equals 3. So now we need to figure out what y is. So we can substitute into either one of those equations. Doesn't matter which one. I think since the bottom equation already is just in terms of y, I'll substitute into that one. And we'll say 5 times 3, that would be 15, plus y is equal to 15. And so that means that y equals 0. And so our answer is 3, 0. So we write that like an ordered pair. And so that means that those two lines, if we graph those two lines on a Cartesian coordinate system, they would intersect at 3, 0. Let's just check our work to make sure we did it right. Let's substitute those two numbers back into the top equation. And we would have 3 minus 4 times 0 is 0 equals 3. And so that is true. We did the problem correctly. So in elimination, the name speaks for itself. Your goal is to eliminate one of the two variables first, and you do this by adding the two equations together, changing them, making equivalent equations out of them. Sometimes you just need to do one of the equations. Sometimes you need to do both of them. Like in practice problem B, we just needed to change the bottom one. So you choose which variable you want to eliminate first. Try to pick the one that would make the least amount of math manipulations. Solve for your first unknown, then substitute that value back into one of the two equations to get the second unknown. Okay, well that's all for lesson 67.